let's figure out the current gain AI. So we're interested in AI this time. We've already established the relationship between AI and AV using this model by analyzing what our end stage is. So, and loading, again, the stage with a load, okay, like RL. So how do we find AI? So we know that AI is going to be equal to the current, the output current, divided by the input current of the system. So that would be IL, load, divided by IN to the stage. Good. So, but that we need something a little more precise than this, because you're not going to measure this. These are AC values. I mean, you can. But the important thing is, can we figure this ratio here based on the values, the actual values of these resistors, including the load, and including any characteristic or impedance values this transistor might have? Well, we know that since we've modeled it here as far as Rin at the base in parallel with RB gives you Rin stage. So, okay, let's break it down into several sections. Let's analyze this circuit right here and extract from it at least IL. Well, we know one thing is IB here is going to be equal to IN times the other resistance, RB, divided by the sum of these two resistors. So this is the current divider rule, beta RE prime plus RE. And from that, we can extract IN at least vis-a-vis IB. Okay, so, and this is on the input side, by the way. So IN is going to be equal to, okay, so if we want to pull out IN, IB times RB plus beta RE prime plus RE, everything divided by RB. Okay, so why did I do this? Why did I want it vis-a-vis IB? The reason is I can figure that out also for IL vis-a-vis IB. So see, if I can model this part right here, the output of the stage, let's go ahead and do that. So for that, inside the model, you have a current generator, beta IB, which produces the current IC, lowercase ic. And from a model point of view, we still have RE right here to ground, since this is the emitter. Notice I'm just concerned with the output. We know that RC is in parallel with all of this and with RL. Now, the current IL is what feeds the load. And we could use here also the current divider rule, in which we evaluate IL. So IL is going to be equal to minus IC, notice because it's in the other direction, times the other resistor, RC, divided by the sum of the resistance, RC plus RL. And let's expand that. Well, that's minus IB beta times RC, so beta IB, divided by RC plus RL. Well, this is good because I have an IB element here. Then we can do something with that. And what can we do? Oh, by the way, this is times all of this. Right? So it's IB times all of this. So this implies that AI now is equal to, and let's put IL at the top here, so minus IB times beta times RC, everything divided by RC plus RL, and all of this divided by IN, which is IB, and again, and if you look at IB, it's times RB plus beta RE prime plus RE, everything divided by RB. What can we do with the IBs? We can get rid of. So now we have AI, and let's look at what we can do here. Beta RC times RB divided by RC plus RL times RB plus beta RE prime plus RE. Okay, and let's not forget the minus that we have right here. And hopefully that should conclude it for AI.